here, a knob. There's a knob over here. Yours is to screw it so that the two ends, the end here and the end here meet. So once the two ends meet, it means that you have gotten the thickness of the paper. The reading will then be taken from the calibrations or the numbering over here. The reading will then be taken from the calibrations or the numbering over here. I believe in our next classes, I will try to demonstrate by video. I'll try to demonstrate by video how the micrometer screw gauge is used. So the object is placed here and then screwed. And whatever measurement you read here, depending on where it has reached, yours is to read. And you read in 2 decimal places. And so you have the main scale and then its supporting scale. Well, in our next class, when I'm able to demonstrate through a video, which I tend to use, you will see how the micrometer screw gauge is used. Now, at the end of the day, what is more important for you to know is that the micrometer screw gauge is used to measure quantities or used to measure materials or objects whose thickness or whose length are very small. It's used to measure quantities or objects whose thickness or whose length are very, very, very small. Thicknesses in millimeters are best measured with a micrometer screw gauge. Now, we also have the vernier caliper, which is used in measuring length. The vernier calipers. We have 2 types. The vernier calipers, we have 2 types. So we have the outside calipers and the inside calipers. We have the outside calipers and the inside calipers. But the bottom line is that they are all calipers. Now, so we have the vernier calipers. The vernier calipers. The vernier calipers, this is how the outside one looks like. You have it this way, and then there's a knob here. There's a knob. So you want to measure the internal diameter of, say, a cup. You want to measure the internal diameter of a cup. You have a cup. You want to know how wide, in terms of diameter, how wide the cup is. Looking at the inside, I'm talking of the internal. You use the outside calipers. The outside calipers will then be used to place around the vernier caliper and place around the object, and you close the knob. Once it tightens the cap, for example, you are using to measure the cap. All right. So you put it around the cap. All right. Once you put it around the cap, you tighten it. You screw the knob until it holds tight to the cap. Now, once you hold tight to the cap, you take the reading. You take the reading from the graduation on the vernier caliper. The inside calipers look like this. We call them the inside calipers. They are designed to measure the inside diameter. They are designed to measure the inside diameter. This is outside diameter. So we have 2 of them. So we have the outside calipers and the inside calipers. But they are all used to measure lengths that are not so small like that's used in measuring the micrometer screw gauge. All right. So lengths like the inside diameter of a cap, the outside diameter of a cap, and all that will be measured using the vernier caliper. Maybe the thickness of this wood, the thickness of the wood, the thickness of your decks, the wood used in making your decks, will be measured using the caliper. Yes. Will be measured using the caliper. And so we now know the outside caliper and the inside caliper. They are both vernier calipers used for measuring such lengths that are not so small, lengths in centimeters, whilst the micrometer screw gauge is used to measure length in millimeters. Now we also have the next quantity, which is volume. So next quantity is volume. We want to learn instruments used to measure the volume. Instruments used to measure the volume. Now, when we talk about the volume is the space occupied. The space occupied by some object or a matter. Now, the volume of any material, say for example, the volume of water in a cup, will be measured using specific instruments. We have instruments such as a measuring cylinder. So you have the measuring cylinder. I believe you have seen the measuring cylinder before. Now, the measuring cylinder is like a thin cap with a broad base. A thin cap with a broad base. And then the object or the substance that is to be measured is poured into it. The object or the substance that is to be measured is poured into it. Let me say that the volume is measured, or we measure the volume of liquids using a measuring cylinder. You cannot determine the volume of solids using a measuring cylinder. So what I'm talking about is measuring volume of liquids. Volume of liquids. So we use the measuring cylinder. So the liquid is poured into the measuring cylinder, and then whatever height it reaches, you then take note of the volume. Since the measuring cylinder is graduated, that is, there are markings on the measuring cylinder. So yours is just to read where the volume has reached. Now, what is more important is, for example, if you have the volume in your measuring cylinder and your volume is this way, let's say this is your volume. Now, what you have to read is the bottom. You have to read the level at the bottom. You have to read the mark at the bottom. You have to read the mark at the bottom, but not here. You are not to read the mark here. You have to read the mark at the bottom. So the mark at the bottom is what we call the meniscus. We call it the meniscus. So all reading of liquids are taken at the meniscus. That is where the bottom is. Taken at where the bottom is. So we will use a measuring cylinder. We will use a measuring cylinder. We'll use a measuring cylinder to measure volume. We'll also use the pipette. We can also use the pipette. We can also use the pipette to measure volume. We can also use the pipette to measure the volume. Now we can also use an instrument we call the burette. Now let me briefly talk about the pipette. The pipette is an instrument made of glass designed to measure specific volumes. So you have the pipette like this. It's made of glass designed to measure specific volumes. So for example, if you want to measure the volume of water in a cup, a specific volume, you pour the liquid into the pipette. Now, for pipette, we have various sizes of the pipette. That is why I said it's used in measuring specific volumes. So we have some pipettes that are 20 centimeter cube.
Yes. One of the boys is asking a question about meniscus.
Yes, the meniscus. Yes, the meniscus, I was saying, is the level that you are going to read. If you have a liquid in a container, let's say in a measuring cylinder, okay? If you have a liquid in a measuring cylinder, the meniscus is said or is known to be the bottom where the reading is to be taken. Where the reading is to be taken. So you don't take the reading from this height. You don't take the reading or you don't take the value from this height. saying that the level of the liquid is here. No, it is wrong. You take the level from here. Remember, you don't take it from here because remember that if you have a shape, let's say the liquid is curved, let's say the liquid is curved inside, and you have a shape like that, remember that all here has no liquid. There are no liquids here. It is the shape of the liquid that has drawn this way. The liquid shape has drawn this way. So you read from the bottom. That is what we call the meniscus. So that bottom where you take the reading from is the meniscus and not the top here. So for readings of volumes of liquid, they are taken at the meniscus. Now, I was talking about pipettes. Now, I said that pipettes, we have specific volumes. They are instruments used to measure specific volumes. We have 20 cm cube pipettes. Some pipettes are 20 cm cube. We also have 25 cm cube pipettes. So let's say we have these two sizes. So depending on the specific volume you want to measure, you then use the pipette capacity you need. Say I want to measure 20 cm cube of the liquid. I use a 20 cm cube pipette already designed. So you are not to go and read anything. You will not read anything because the pipette has already been designed or measured or already created for you. It's a 20 cm cube. Then we also have the 25 cm cube, which is specific. So for pipettes, they are already specific volumes where you will not read after you have poured the liquid into them. You don't read, unlike the measuring cylinder, where you have to read from the meniscus, where you have to read from the meniscus the level of the liquid in the cylinder. Now, the burette is also just like a pipette. It works exactly like a pipette, only that the burettes are bigger than the pipettes. Only that the burettes are bigger than the pipettes. The burettes, we have capacity of 50 cm cube, very big than the pipettes. So they are used to measure specific volume, specific volume, specific volume. So for volume of liquids, we use these instruments to measure volume of liquids. Now let's go to the next quantity, time. Time. Let's go to the next quantity, time. After this, I will give you some assignment to do. Now, all right, time. Now, we have instruments used in measuring time. We have the stopwatch or stop clock. So we call stop clock or watch. You have seen in athletics this instrument used by referees and track judges. In athletics competition, they use the stopwatch. So the stopwatch has been designed so that it can measure time in microseconds and seconds. So it means that you have time in microseconds even within the time. So if in 100 meters race from one point to another point, which is 100 meters, we then use a stopwatch where we start the time and the microseconds begin to turn into seconds. I believe you have seen a stopwatch before. You have it on most phones. So you have it there. It is even written the stopwatch as one of the apps or one of the tools on the phones. So stopwatch is an instrument used to measure time. No matter the shortest time, we can measure it, even in microseconds. Then we also have the normal clock or watch, where there is, we also have the normal clock or watch. The reason why we call it the stopwatch is that here you stop at exactly when you need to stop, or you stop at when you really want to stop. But for the clock, it is always moving. You have to take note of when the activity began, or when the event began, and when the event is ending. So the distance between when the event began and when the event is ending is what you will calculate. But for the stopwatch, it already gives you the straight away time. That is the difference between the stopwatch and the normal watch. Now, having said this, we have looked at 3 quantities and they are measuring. Let us see what you have learned. By looking at these measurements,
please, what about digital watch?
Yes, we have the digital watch too. The digital watches are what some people call disco watch, where the time is in numbers. Okay, and then it blinks or it counts. So that one too can be used in measuring time, because once an activity began and you take note of the time, and then the activity ends and you take note of the time, you are able to know how long the activity has taken. So once you're able to know how long the activity has taken, either in seconds or microseconds, you are able to give the time. Now, I would like us to see what we have done so far. We have looked at length, the instruments used in measuring length. These are the instruments: the surveyor's tape, the tape measure, the micrometer, screw gauge, the vernier calipers are all used in measuring lengths of objects or quantities. Then we look at volume also. The measuring cylinder, the pipette, the burette are all used in measuring volume of liquids. Please take note, this is volume of liquids. This is volume of liquids. Let me even put it there. Then we have the time. Instrument used in measuring time, stopwatch or clock, or the normal clock, or the digital clock, as we said. Now, so you have all these instruments. Can I find out from you if any one of you have questions? Any question from any of you? Any question from any of you? Yes, are you all in the class?
Hello, unmute your mics and ask questions bothering your mind.
Any question from any of you? Do you understand what we have just talked about? We talked of the instruments. All right.
Sir, please, what is the difference between pipette and burette?
Yes, the difference between a pipette and a burette is this. The pipette is a shorter instrument. It's used to measure very small volumes, highly small compared to the burette. The burette can measure about twice what the pipette will do. So for very small volumes, like maybe you are taking an injection, which is about say 5 cm cube, you will measure it using a burette. It will be more accurate using a pipette than using a burette. Because the bigger the volume, you need to use a burette to give you accurate reading than to see the bigger or the smaller they see in a larger instrument. You don't need to see the smaller volume in a large instrument like a burette. Yeah, so I would like to give you this.
Sir, please, is a pipette plastic? Can it be plastic?
No, pipettes are always glass. They are always glass. Why? Because what happens is that when it is plastic, maybe you want to measure the volume of an acid. You know, acids are highly corrosive. Acids can burn the plastic. But for glass, it wouldn't react with the glass. So glass will be able to keep, whether they are corrosive or not, glass will be able to handle them. So we normally make them of glass. So we have them in our various labs, and anytime you come to school, you come and see them for yourself. The pipette and the burette.
To measure time accurately, can we use atomic clock?
You said to measure time accurately, can we use what?
Atomic clock.
Can we use the atomic clock? Yes, but it is not a common clock. It's not a clock that is available even in industries and even in our schools. In our school here, we have a stop clock and we have a normal clock. These are common instruments that we can use for our daily measurement of time. Yes, you can use the atomic clock, but it's not common. Thank you for your question.
Okay.
Our time is running out. Can you take this? Get the following instruments for me. Instruments used in measuring electric potential. Once again, I'm asking of electric potential, but we are looking at instruments used in measuring electric potential and electric current. Instruments used in measuring electric potential and electric current.
Sir, please, I want to ask that the atomic clock and the normal clock or watch, are they different or they are similar?
They are different. They are different, but they are all able to measure time. But the atomic clock is not common. That is the thing. We don't even have it in the school here. It's not common. It's not common. So you can't say you are going to measure time, so you are looking for atomic clock to use when you even have even stopwatch on your phone. So we'll use the most common tools for the clock. Okay. So how we get the instrument used in measuring electric potential, what we also call voltage, and then electric current. Get the instruments used in measuring these two quantities. So that in our next class, we will be looking at these quantities we have mentioned. That is the length, the volume, the time. We shall be looking at the formula for measuring the volume. For example, volume of a solid, volume of a liquid. So these are the things we shall be talking about in our next class. Thank you very much and have a blessed evening. See you tomorrow when we have our class test.
Hello. Hello. Good afternoon.
Oh, sir.
We thank God that we have a successful integrated science class this afternoon. But we have light off at our end here, but we are able to manage. And please, the payment is very, very necessary. It is very, very necessary. If you want the class to continue, then you must do your part. We said that we have done our part. That is, for the Bible, we have done our part. So it is left at your side. We are doing our best. Very, very our best that we can do to sustain this. We are doing it. So please and please do your part. Okay? Okay. So that next week all of us will continue to learn. All of us will continue to learn. So that nobody will be neglected for not being. All right. So as usual, we want to take our grace. Okay, hello. Let's share the grace. May the grace of our Lord Jesus Christ, and the fellowship of the Holy Spirit be with us now and forevermore. Surely, goodness and mercy shall follow us all the days of our lives, and we shall dwell in the house of the Lord forever and ever. Amen. Tell a friend that it is class is going on Zoom. Okay. Bye-bye.
Bye.
Não se vai,